Hello, sixth graders. Welcome to sixth grade math prime factorization. Pause while you write the lesson title in your interactive student notebook. Pause again while you write today's lesson objective. Today's objective is, I can express a number as its prime factorization by completing practice problems with 100% accuracy in multiple attempts. The Arizona State Standard we'll be working on today is interpret a context to construct an equivalent expression using the greatest common factor, least common multiple, and the distributive property. Remember, if your vocabulary is not yet written in your math notebook in words worth knowing, you need to make sure that it gets there. Let's review what a factor pair is. Because 2 is a factor of 10 and 2 times 5 equals 10, 5 is also a factor of 10. The pair 2 and 5 is called a factor pair of 10. So let's get started with example 1. Finding factor pairs. So the brass section of a marching band has 30 members. The band director arranges the brass section in rows. Each row has the same number of members. How many possible arrangements are there? So what you need to do here is you need to find all of the ways that you can multiply to get to 30. So all of the factor pairs for 30. So it says use the factor pairs of 30 to find the number of arrangements. You could multiply 1 by 30. So there could be one row of 30 or 30 rows of 1. You could multiply 2 times 15. So there could be 2 rows of 15 or 15 rows of 2. You could multiply 3 times 10. There could be 3 rows of 10 or 10 rows of 3. You can multiply 5 times 6. There could be 5 rows of 6 or 6 rows of 5. And then you get to 6 times 5. And that gives you, that is repeating. So since you are repeating, you know you're done. You know that there aren't any more factors. So one way to do this is to make a factor rainbow. Let's look at our study tip over here. It says when making an organized list of factor pairs, stop finding pairs when the factors begin to repeat. So it says there are 8 possible arrangements, 1 row of 30, 30 rows of 1, 2 rows of 15, 15 rows of 2, 3 rows of 10, 10 rows of 3, 5 rows of 6, or 6 rows of 5. So I mentioned a factor rainbow. I'm going to go ahead and do one of those down here for 30 so that you know what that looks like if that's new to you. So you always start a factor rainbow with 1 because 1 is a factor of every number. And 1 times 30 is 30. And 30 is even, so we know that 2 goes into 30. 2 times 15 is 30. And 30 is divisible by 3. So 3 times 10 is 30. 30 is not divisible by 4. 30 is divisible by 5. We know that because 30 ends in a 0. And 5 times 6 is 30. And then we repeat because our next number is 6. So we know it's time for us to stop. Now we're going to write a prime factorization. So you have to be pretty solid on your factors and your factor pairs in order to write a prime factorization. One of the rules of factor trees is that there are no ones allowed in factor trees. So make a note of that in your notebook. No ones in factor trees. And that's because ones are not prime numbers and they are not composite numbers, so they don't really fit into factor trees. And because multiplying a number by 1, you're also multiplying by itself, so it doesn't help you get to the prime factorization. So we are going to get started. One of the first things to notice is this study tip off to the left. It says, notice that beginning with different factor pairs results in the same prime factorization. Every composite number has only one prime factorization. So we're going to prove this out for you. So it says we're going to write the prime factorization of 48. So it says choose any factor pair to begin the factor tree. So when it says that, it means any one except 1 times 48, because there's no ones in factor trees. So let's go to tree 1. 48 is 2 times 24, and we circle the 2 because it is a prime number. And then we look at 24. It's not a prime number. So two numbers that multiply together to equal 24 are 2 times 12. This 2 is circled as well. 12 is not circled because it's not prime. Remember, 2 is the only even prime number. Write that in your notes. So we look at 12. 4 times 3 equals 12. 3 is prime, 4 is not. 2 times 2 is 4, so we circle those 2's. So 48's prime factorization is 2 times 2 times 3 times 2 times 2. And then let's look at tree number 2, 48, and it says find a factor pair and draw branches. So 3 times 16 is also 48. We circle the 3 because it's prime. 2 times 8 equals 16. We circle the 2 because it's prime. 8 is not. 4 times 2 is 8. We circle the 2 because it's prime. 2 times 2 is 4. So 3 times 2 times 2 times 2 times 2. And even though these are in different orders, they're exactly the same because they have the same number. They have the same numbers in them. So the prime factorization of 48 is 2 times 2 times 2 times 2 times 3, or 2 to the 4th power times 3. Example 3 is about using a prime factorization. It says, what is the greatest perfect square? So we talked about perfect squares in our last lesson. That is a factor of 1,575. So we're going to take that giant number, 1,575, and we're going to find the prime factorization. So it says, because 1,575 has many factors, it is not efficient to list all of its factors and check for perfect squares. So doing a factor rainbow would be horrible for this number. Use the prime factorization of this number to find any perfect squares that are factors. So we start with 25, and we can guess that 25 is a factor of 1575 because it ends in 75, and we know that 25 goes into 75. So then if you do the math, you can figure out that 25 times 63 equals 1575. And neither of those two numbers are prime. So even though 2 is the only even prime number, that does not mean that all odd numbers are prime. So 25 is equal to 5 times 5. So we circled those two. And 63 equals 7 times 9. 7 is prime. 9 is not. It's an odd number, but it is not prime. 9 equals 3 times 3. The 3's are prime. So 1,575 equals 3 times 3 times 5 times 5 times 7. The prime factorization shows that 1575 has 3 factors other than 1 that are perfect squares. So 3 times 3 equals 9. That's a perfect square. 5 times 5 equals 25. So see how these are up here and they're showing us. And if we look at what else we've got, we have a 3 times 5 in here and another 3 times 5 in our prime factorization. So that's where they're getting that 3 times 5 times 3 times 5. And 3 times 5 equals 15. And the other 3 times 5 equals 15. And 15 times 15 equals 225. So the greatest perfect square that is a factor of 1575 is 225. So remember, your next steps are to be sure your notes in your interactive student notebook are complete. Finish your Google form questions and review the lesson if you need to. So if you're not understanding it, you need to look back at it and view it again. Complete your Big Ideas math assignment in your Math Spiral notebook and submit that when it is 100% correct, and track your progress on your playlist.